Hello everyone, welcome to our 5th pre-recorded video, and this is going to be on chapter 6, mainly sinusoids, and it's your 5th homework. So we're going to once again do a couple problems, but first want to explain a little bit about sinusoids. So on the left at the top here we have a sine wave right here. We have a sine wave. And this sine wave is represented by the following function up top here. And so this sine wave, oh my bad, this sine wave has an amplitude A times the sine of 1 over t, where t is the period or how long it takes for one cycle, which is marked right here. T, which 1 over t is actually our frequency, which we'll get to, plus our phase. Now, the cosine is actually a phase shift of sine, and it's a phase shift of 90 degrees. So it shifts, if we add 90 degrees or pi over 2 here for phase, in this, we're going to actually get this. Because if we have a, actually we'll get to that a little bit later. But so, once again, if we have a phase shift of 90 degrees, it's going to equal a cosine wave, where A is our amplitude, or how high these graphs reach. So A is the maximum height, and minus A is the minimum height of the cosine, and it's pretty much the same formula. The only difference is that it's a cosine wave instead of a sine wave. So A is our amplitude, T is our period, or how long it takes to complete one cycle. Frequency, our F, is 1 over our period, and that's in hertz. Then we have our angular frequency, which is represented by omega. Omega is equal to our angular frequency, which is radians per second. We have our phase, and we also have a time shift. So if we see a graph is shifted, so this one now starts at let's just say here, so I'm just going to use this cosine example. So we now have a shifted cosine, but we're only given the shift along t, which is time in seconds. We can then find what the phase is by having our time shift multiplied by our angular frequency, and that will give us the phase. So this is pretty important and something we'll need to use in the homework problems. But the first problem that I want to go over is 6. Let's see. Let's take a look. 6-8. 6-8 is a good problem. So we'll go at 6-8, and we're given a cosine graph, which looks like the following. Alright, and we have a amplitude of 5 right here, where we have 5 there, and we're told that this is 1 over 30. Well, 30. This is t in seconds, and this point right here, or one complete cycle, is 1 over 15, and this is in seconds. Let me rewrite that. That looks horrible. Alright, that's seconds. 1 over 15 seconds. And we are asked to find the amplitude, the period, the frequency, and the phase angle. Alright, so let's start with A. And if we go back to the previous page, we see that amplitude is the height of our graph, is A. And if we come back here, we see that the amplitude is 5. So we could say A is equal to 5. And this is in centimeters because the graph is a position graph. So there's the first one. The next, it wants us to find our period, t. And if we remember, the period is how long it takes to complete one full cycle, which is what we see right here. And we're given that. We're given as 1 over 15. So period is equal to 1 over 15 seconds. So we got two things right off the bat. Very easy. Now, the third one is frequency. And like we said before, frequency is equal to 1 over the period. Now 1 over 15 is equal to 15. So, and this is in hertz. So we have our amplitude, our frequency, and now our phase. So our phase angle, if we're thinking of this as a cosine graph, is just equal to 0. There is no phase angle. There's no phase shift at all because we're saying that this is a cosine. So phase is 0 degrees. And that's because we can then represent this as 5 I'm sorry, let me make one adjustment up here. Is I have this as 1 over t pi. This should be 2 pi. I'm sorry. 2 pi. Let me erase it up here. This should be 2 pi over our period because we want to work in terms of radians. And so our frequency is 1 over 2 pi. So our angular frequency is actually 2 pi f. So really, as this we could replace this part right here with omega. So it looks kind of sloppy. I'll rewrite it over here. So we would then rewrite this as 5 times the cosine of omega up omega t plus our phase angle. Omega t, which is a function of time, that's our variable, plus our phase angle. And so omega, like we said before, is equal to 2 pi times our frequency, so 2 pi f. So we can then rewrite this as 5 times the cosine of 2 pi times 15t plus 0, which equals 5 times the cosine of 30 pi. Like I mentioned before, though, we can also represent this as a sine wave, which would have a phase shift of 90 degrees. So if we represented this as a sine wave, the only difference would be this phase angle, which we would say would be 90 degrees or pi over 2. Pi over 2. So it's just a representation of how you want to have it. You could either have it in terms of cosine, which would be this term, or you could replace everything with a sine and then make it switch up the phase angle so that it's pi over 2. So we would just add a pi over 2 component and it would give us this. So one thing that I do want to mention is that if we have a phase shift, if we have a positive phase shift means that we're shifting to the left. The shift to the left. So if we have a negative phase, if we have it as a negative, this is a shift to the right. So it's kind of the opposite of what you would think it would be. So because of, we would think, all right, well, this is the negative axis along the x term, so we would go, if we have a shift, we want to go in this way. Well, that's not what we want to do. We actually want to go to the right. And if we have a positive, we would shift left. So that's why how we saw that the sine wave, which originally starts out like that, with a positive pi over 2 shift or a 90-degree shift, this is going to shift this way, which then makes it look like this. Right? So here would be our mark right there of pi over 2. That's pi over 2, right? Because one cycle is equal to 2 pi. This is equal to pi. So shift of pi over 2 then just moves this graph to the left at pi over 2. And actually, if we wanted to continue it, it would look like that. So that's just something that you'll need to know to answer some of these homeworks if you don't know already. So the next problem that I want to go over is 614. Let me erase it. 614. So we're given an equation x of t, which equals 10 times the sine of 4 pi t minus pi over 2, right? So what this asks is to find the amplitude, the frequency, the period, and the time shift. Not just the phase shift, the time shift. So for part A, looking at an equation and looking to what we did before, A is just the amplitude, right? Or the coefficient term multiplied by the sine is our amplitude. So looking at this, we could say our amplitude A is just equal to 10. So that's one. The next that we were asked for is frequency. However, the frequency is computed from the angular frequency. So we have F, which equals to omega, or 2 pi, I'm sorry, let me rewrite this. Omega, which is this term right here, the 4 pi, is equal to 2 pi f. So if we want to find f is just equal to omega over 2 pi, which is equal to 4 pi over 2 pi, which equals 2. So 4 pi over 2 pi, the pi's will cancel, and then you just do 4 divided by 2, which is 2. So F is equal to 2 hertz. The next part of this asks for tau, or our time shift. And tau, we said, was our phase shift over our over omega. So this is just equal to pi over minus pi over 2 divided by our omega, or angular frequency, which we said before was 2 pi. Or 4 pi, 4 pi. So now this is equal to negative 1 over 8 seconds. So we were able to find our amplitude, our frequency, and this is tau, our time shift. And that's all part A asks us. Now part B asks us first time to reach x of t is 0 and x of t at 10 centimeters. So what we're going to want to do for this is plug in 10. So we want to plug in x at 10 and x at 0 and see what we get. So if we have x equal to 10 at 1/4 t, or a quarter of our period, 1/4 t plus tau, or our phase shift, this comes out to equal 1/4, and we know our period is 1/2, and we know that from tau, or we know that from 1 over the frequency. We have our frequency, so we multiply this by 1/2, because our frequency is 2, and we add our time shift, 1 over 8, which equals 1/4 seconds. And then we want to find when x equals 0 at the same thing, so we do t over 2 plus tail, which equals 1/2 times another 1/2 plus 1/2. No, is it 1/2? No, t is our period at 0, so we would actually be at 0 seconds. So our it would be 0 plus. No, I'm doing. This doesn't look right. The solutions that I have. Alright. Hold up. Let me erase this. So, really, it's going to be 1/2 times another 1/2, which equals 1/4, minus the 1/8, which is going to give us 1/8 seconds. Alright, now for the final one is C. C asks us to then plot, and because we know the time shift, and we were given a sine wave, actually we were given a sine wave, we know what an original sine wave looks like, but we now want to look at a shifted time sine wave. So what we would do is we can first draw an original sine wave, and we know that it's now shifted by half of a, or 1/8 of a second. So the shift then comes from, we could say right here is 1/8 of a second, and we really start our new graph, our new sine wave right there, and that goes through. So with the time shift of 1/8, we know that we would shift our original sine wave over 1/8 of a second and recreate it this way. And our amplitude still stays the same, which was 10 to the negative 10. And we would just add 1/8 to right here would be pi over 2. That's pi. This is 3 pi over 2, and this is 2 pi. And if we wanted to get those terms in terms of seconds, we would have what, pi over 2 divided by our angular frequency. So this is equal to pi over 2 divided by what was our angular frequency? 4 pi over 4 pi, which would then equal to 1 over 4 times 2, which equals 1 over 8. So this point right here then is 1 over 8 plus 1 over 8. So this is really a negative cosine wave. And this would equal to 2/8 or 1/4 second. So we'll go over more of this in recitation, and hopefully in class you'll learn all about it. So once again, if there's any more questions, just ask me during recitation or shoot me an email. All right, thank you guys.